Hi everyone, this is a self-guided, highly structured training course that offers you the possibility to learn everything about full-stack development with Nextjs. You are going to learn not only backend development but also front-end development, and at the end of this course, you will be able to build your own app from scratch at your own. Whether you are a beginner or not in Nextjs, the only thing you need is to have some basic knowledge in JavaScript and a lot of motivation. So, are you ready? Let's get started. You are literally the first developers to have access to this course, in which you will learn how to create your own application from scratch using the most popular JavaScript framework, Nextjs. This course is not a tutorial. It's a complete program that will allow you to learn how to create a full-stack application with Nextjs. My name is Sylvaincodes, and throughout this course, I'll guide you every step of the way. Alright, this course is for beginners in JavaScript. I mean any JavaScript developer who wants to gain full-stack experience and build full-stack applications with Nextjs. Also, intermediate web developers who are ready to improve their Nextjs skills, either for front-end or back-end development. And also, passionate learners if you are enthusiastic about web development, to have a strong drive to learn regardless of your current skill level. You are welcome. This course is divided into two parts. The first part is about backend development, and the second part is about front-end development. In this part, we are going to have a brief overview of what a backend developer is and what his responsibilities are in a company. Then we'll talk about the project you'll be working on in this course. A backend developer is one of the most important persons in a company, and you will understand why. In fact, in a digital world, almost every company has a website or uses software and IT systems. Backend development helps to keep these systems running. A backend developer's responsibilities include creating, maintaining, testing, and debugging the entire backend of an application or a system. He also has enough computer science background. In 2 words, I can say that the role of a backend developer in a company is to secure data. This means, as a backend developer, you will need to know how to design robust APIs using a programming language or framework so that supporting mobile and desktop clients can communicate with databases to store, understand, and delete data. You also need to have experience with databases such as MongoDB, Postgres, MySQL, and so on. A backend developer also deals with cloud solutions such as Amazon Web Services, Google Cloud Platform, or Microsoft Azure. Why? Because these platforms provide flexible, scalable, and high infrastructure to secure databases and servers. This video will cover all those aspects, but instead of those cloud solutions I just mentioned, we are going to use Vercel. Vercel is a cloud platform for static frontends and serverless functionality. It allows developers to host websites and web applications that can be deployed instantly. Unlike AWS, Microsoft Azure, Google Clouds, which can take a significant time to learn and aren't free, Vercel is the best solution to start with. In short, at the end of this part, you will improve your technical backend skills such as understanding API principles, creating RESTful API using Nextjs, integrating query and aggregate using Mongoose, performing server-side validation using Zod Validator, securing your APIs with Clerk version 5 Auth token, setting advanced role-based security token using Clerk, setting CORS headers for your APIs, route handlers to allow which origin should have access to your APIs, documenting your API using Swagger and OpenAI, finally, deploying your API into production using Vercel. In a few seconds, we'll talk about the project we are going to build. All right, let's talk about the project we are going to build. This is a software as a service multi-vendor marketplace platform. A multi-vendor marketplace is an e-commerce platform that allows multiple vendors to sell their products from a single storefront. Think about Amazon or eBay when you think of multi-vendor. Unlike a single storefront, a multi-vendor e-commerce has three users: the owner, the sellers, and the customers. The owner is the manager of the platform. Sellers are people selling products. Customers are people who buy products from sellers. A seller can be you or anyone else who wants to sell a product. You can visit the store, click on Become a Seller, then click on Join for free. Afterward, you need to create an account using Google account or your email address. And then create your first store. Once approved, your store is online and you can create products and takes orders. A product has multiple attributes, some of which are required, such as images, name, description, price, options, categories, subcategories, brand, and more. You must enter a value for each required attribute in order to save your product. A product may have several options. Click on the option button, then select the option you want to add. Afterward, select a value from the list below. If the value does not exist, you can create one and press Enter. By the way, you can add a color to an option as well as an image. We'll be using Cloudinary to upload media assets in bulk with a variety of options. Cloudinary provides a secure and comprehensive API to easily upload media files from server-side code directly from the browser or from a mobile application. Of course, we have two separate environments, one for the production application and another one for a test application. I'm in the test application right now, which means that anything I add or update will not be added to the main application. So you can do whatever you want, like create a product, create a shipment, manage and order. There's no worries. Now, when a seller creates a shop, the owner will have to approve this shop in order for the seller's products to be available on the market. So we are on the seller dashboard right now. And to have access to the admin dashboard, you need to change your account from seller to admin. For that, go to the setting page, click switch account, then log out and log in again. All right, we are in the admin dashboard right now. We have 3 stores, 3 members, and no revenue. You can see all the categories, subcategory, tag, and so more. But what we are going to do is to approve the seller's store. So let's go to vendors page, then click on seller's store. Afterward, we are going to update the status of this store. Now it's going to be online. A seller can have a free account, but also a premium account with a lot of features that allow you to grow your store quickly, like the possibility to create multiple stores, make campaigns to promote products on the store, and more. Now you may want to switch back your account from admin to seller. So this is the same way. Go to setting page and click on switch my account. Then log out and log in again to have your store account. So for more information, go to the marketing page, click on documentation. You will have everything you need. When it's come to build a software, it's important to consider the software development lifecycle known as the SDLC. This is a systematic process to develop high-quality software in a predictable time frame and budget. The goal of this process is to produce software that meets client business requirements. This is a cycle of planning, designing, and development that can be implemented as an iterative approach. There are generally 6 phases in the SDLC process: planning, design, development, testing, deployment, and maintenance. In the first stage of the SDLC, the planning phase, requirements are gathered, analyzed, documented, and prioritized by the product manager and the customer. When all these informations are gathered, they will be analyzed and prioritized in terms of the customer's desire. For example, to build this project, I use Jira to create and gather all projects requirements, and then I prioritize requirements according to their importance. Afterward, these requirements have been documented in the SRS, which is the software requirement specifications. This document is used to develop in the design phase the software architecture. So at this stage, we discuss about the architecture of the software. I mean, what programming language, what framework, what database system are we going to use? And what cloud solution are we going to use, and so on. At the end of this phase, we have a document called design document. And this document is used by developers during the next phase, which is the development phase. The development phase, also called building phase or the implementation phase, is when the developers start coding process once the design document is completed. And at this point, the lead developer uses the design document to determine and assign coding tasks for each kind of developer, both front-end and back-end. And they might also have standards or guidelines that need to be followed. For instance, after this phase, we have the testing phase. This phase includes QA teams and involves rigorous evaluation of the software to identify and correct any defects or issues. The primary objective is to ensure the application works according to the customer requirements in the SRS. Next is where the application is released into the testing environment and made available to customer. Once customers sign off on the functionality, it's released on production environment. Finally, the maintenance phase happens once the code has been deployed into a production. This phase helps to find any other bugs, also to identify any other requirements that may not be listed in the SRS, but also if bugs are discovered in this phase that were missed during the testing phase, these errors may be to be fixed for higher priority issues or simply incorporated into the requirements as part of a future software released, and the process can start over again. Now, let's start with development phase. At this phase, we are going to set up database. According to the design document, we are going to use for the backend TypeScript as programming language, Nextjs as backend JavaScript framework, MongoDB database with Mongoose ORM, Clerk for authentication, Zone validator for server-side validation, Axios as HTTP client, Cloudinary as media management service, Vercel as cloud solution, Git as version control platform, GitHub Actions as CI/CD platform, Swagger and OpenAI to document APIs, and Stripe payments. We'll start development phase by setting our environment. First of all, we need to create the GitHub project. Git is a free and open source distributed version control system. It is used to store the source code for a project and track the complete history of all changes to that code. For that, Git enables you to use many commands such as git add, git commit, git push, and so on. You can also use GitHub, which is developers platform that allows developers to create, store, manage, and share their code. Now go to github.com. After login to your account, create a new repository called YouTube ORION API. Now we are going to create our Nextjs project with ChatCN. So let's go to ChatCN website. From the installation section, click on Nextjs and then copy this command. Now open your terminal and go to the directory you want to save the Nextjs project. And then paste the ChatCN command right here. It's going to install not only ChatCN library but also the Nextjs project. Now, open your code editor. Personally, my favorite code editor is VS Code. If you use VS Code, this is great. I'm going to give you a lot of tips, like which extension you should use, both for frontend and backend. Now open your project. Okay, this is our Next.js project. Let's see. We are going to use Next.js 14, React 18, and TypeScript version 5. Now open your terminal, go to the project directory. If you're on Mac, Windows, I don't know, go to the directory. And let's go back to the project repository. Here we do not need the git init anymore. Git add readme neither, but we should use a git commit. So get back to the terminal. Okay, we are going to add the git add command first. And then put the git commit. Nice. The project is now available on GitHub. Great job. Now, if you are using VS Code, close your terminal. We are going to use VS Code's terminal. Go to terminal menu, select new terminal. Now, run npm run dev to start your Nextjs development server on port 3000. Then open this on your browser. Your homepage should look like this. The next step is to set up CI/CD. CI/CD refers to the practices of continuous integration in either continuous delivery or continuous deployment. CI ensures that all the code components work together smoothly. A CI-built environment enables you to integrate newly developed code frequently. Continuous delivery begins when CI ends. The CI process automatically builds and tests your code. Then CD deploys code changes in a build to a testing or staging environment. So let's make a folder called .github. Inside this one, we will make another folder called workflows. And in this folder, we will make a file called continuous deployment on Vercel .yml. A workflow is an automated process made up of one or more jobs. Workflow files use YAML syntax and must have these extensions. With GitHub Actions, you must store workflow files in the GitHub Workflows directory of your repository. Now we got to implement our first workflow. Vercel has built a very simple configuration with GitHub Action for us. So what I'm going to do is search Vercel GitHub Action deploy. And copy this configuration, go back to VS Code and pass it. A workflow has many attributes such as name, inf, on, jobs, and so more. Each one has a specific functions. For example, name is the title that will be displayed under your repository's action tab. Env attributes allows you to specify some variables. The next one is on. A workflow is a process. So, to run this process, we need an event. This event can be triggered by the attribute on. We use on to define which events can cause the workflow to run. There's a bunch of events out there, such as push event, release event, pull request event, workflow dispatch event. These are the most popular events. Let's talk about the workflow dispatch event. This is a kind of event which allows you to trigger an event manually. And we will try that later in your repository. The next attribute is jobs. A workflow can have one or more jobs. A job is used to run multiple tasks. For example, we can have a task to install Vercel, another one to pull our project to Vercel, and another one to build our project and deploy our project to Vercel. Now, to deploy our project, we need to set up variables. And for that, go to the repository, settings section. Afterward, select secret and variables, select actions. In secret section, create new secret. You have to create your Vercel organization ID. This ID is available from your Vercel account. Go to your Vercel account, click on your profile, select account setting, scroll down. There you can see your ID. Click on copy. Now we also need to create two more ID. One for your test environment and another one for production environment. And for that, we actually need to create two deployments. So go back to Vercel, connect your GitHub account with Vercel, then Vercel will load all your repository. Then select your repository, click on import. Now go back to the project setting. Scroll down, you will see your project ID there. Copy this ID, go back to your repository and pass your ID there. We need now to create another secret ID, which is the ID for the production environment. We are going to create another project. Perfect. As you can see, we just created two projects from the same Git repository. For that, we are going to create another branch called production. Okay, so go back to your repository, click on branch, create new branch called production, and from your Vercel dashboard, you will have a project for a specific branch. So the first project is for your main branch, and the second project is for your production branch. That's why I updated the branch for the second project from main to production branch. Okay, now what is the next step? The next step is we are going to update this workflow for your test environment. For that, come up here. Instead of Vercel project ID, you will put Vercel project ID test. Okay, then here we have environment preview. Okay, and for that, I think we are good. Now we are going to create another workflow, and it's going to be for your production environment. So copy this file and paste. Okay, add at the end of the name just prod. Then open the file, and instead of Vercel project ID test, put Vercel project ID production. Nice. And it's not over. You will also have to update this command right here. Instead of preview, put production. This command as well, we are going to add the production environment there and here. Okay. Update the title of your workflow, Vercel production deployment. And now we need to change the event. It's going to be workflow dispatch. There's last thing that we need to do. We are going to create a file called Vercel.json. In this file, we are going to tell Vercel to not update automatically our project from the GitHub repository. So let's create a key called gate. Inside this, another key called deployment enabled, and we are going to add a branch main, which is false, another branch production false as well. Update the repository with git add command, git commit, and git push. Great. Let's do a simple trick. We are going to change the test right here. This test, this content right here. Go to page, put any content like update workflow. Nice. Now push your change on the repository. And let's see if Vercel has. So as you can see, Vercel did not update our project. So to update our project, we are going to trigger the workflow. Go back to your repository. Go to action section. Here you have workflows, Vercel preview deployment for test environment, Vercel production deployment for production environment. Okay, click on preview deployment. Click right here, run workflow, and you can run your workflow manually. Go to your Vercel project, reload the page, great, the project is updated. Now, if you want to update the production environment, you do the same way. First of all, select Vercel production deployment. Then click on run workflow. Select the branch production. Workflow does not exist or does not have a workflow dispatch trigger in this point. Great. Go back to your repository, select production. Okay, there, as you can see, we don't have the GitHub workflows directory. So you need to update this branch, okay, by running a pull request. So first, click on this. Create pull request. Update production branch. Okay, nice. Let's go back to our repository. Select production branch. Okay, we are good. Now let's go to action. Select version production deployment. Run workflow. Select production. And you can update your production project by running this workflow. Okay. First of all, let's see if production visit. As you can see right now, the YouTube ORION API production do not have the test update workflow. So this is what we are going to do right now. Run the workflow, okay? Now, let's summarize. Firstly, create your repository, then create another branch called production. Afterwards, create two projects on Vercel for each branch. Create two workflows in the GitHub Workflows directory. Create a file in your root project to disable automatic deployment. When you push your changes to the main branch, you need to trigger the workflow on this branch to deploy and update your content to the test environment project on Vercel. After that, if you want to deploy on your production environment, create and confirm the pull request, then trigger the specific workflow from the production branch to deploy your change to production. Now, we are going to set up variables for each environment. For example, the test environment will not have the same database as the production environment. To start with, we need 3 env files. a local development env file which will contain the development variables, a local test env file which will have the test variables, and so on. Firstly, we'll have next.js URL, such as the Nest public server URL, but also the Nest public API URL. After that, we'll have the database URL and Stripe APIs, Clerk APIs. It's going to be the same variables for production and test as well. Let's talk about databases. There are two different types of database. SQL databases, and NoSQL databases. SQL databases are relational and use a structured schema. Data is organized into tables with predefined columns and data types. NoSQL databases are non-relational and can store unstructured, semi-structured, or structured data. They do not require a fixed schema, allowing for more flexibility in data modeling. If you are new to databases, you are wondering which type of database should I learn? The choice between SQL and NoSQL depends on the specific needs of your application. In this course, we will be using MongoDB. To start, let's create a MongoDB account. Search for MongoDB. Go to the website. Click on Create a new account with Google or GitHub. Then you need to create a new project. Put a name for your project and click on Next. Now we are going to create a cluster. Select a free cluster. Afterward, we are going to edit network access to allow anyone. Click Add New Address. And put this address. Then save and go back to cluster configuration. Now we are going to create a new user. You can put whatever you want. Afterwards, we are going to install some dependencies like Mongoose. Click on Driver, select Mongoose, select the latest version, copy this command, go back to your VS Code editor and paste the command. Mongoose is an object document mapper for MongoDB. It provides a very easy way to model data and interact with MongoDB databases using schemas. With Mongo, you can define the structure of your document. We are going to install Compass. Compass is a graphical user interface tool for managing and analyzing MongoDB databases. Now we are going to add MongoDB connection string to our application. Copy this string back in your VS Code editor. We actually need to set MongoDB URL and also add a database. As you can see, I add three databases: dev, desk, and production. Now, if you have successfully installed your MongoDB Compass, this is what it looks like. Click on Add New Connection and just copy the MongoDB URL without the database, and it's going to load all databases available from this URL. If you set database in the link, you are not going to load all databases, but just one. Now, we are going to connect our Nextjs project with MongoDB database. So first, we need to create a connection file. Inside lib directory, create a new file called dbconnect.ts. Firstly, we are going to import Mongoose from Mongoose. Then export a function called dbconnect. Afterward, we are going to check if Mongoose is already connected with this function. If Mongoose dot connection dot read state so return nothing. Else Mongoose dot connect get process dot env dot mongo URL. Okay. As string. Nice. Afterward, in the app directory, create another directory called API, which is the APIs directory. Inside this, create another folder called test, for example, and create a file called routes.typescript. We are going to create our first API, very simple, to test if our MongoDB is connected with our Nextjs project. First of all, import MongoDB connection, db connect, okay, then export async function get, then we will try to connect to database, and we are going to return a response JSON with a status 200. Let's put something here. Message. Okay. To use this API, go on localhost 3000 API test. We need actually to run our project. Perfect. How do we know if our Nextjs project is connected? Inside db connect, I'm going to add console log, the console log connected, already connected, and here first connection. Let's reload, and in the terminal you can see we have already connected. Good. Now we are going to set up Jest. Jest is a JavaScript test framework which allows you to run tests in your application. So first of all, search for Jest, es.io. Click on Get Started. Copy this command. Open your terminal. Create another space. And run the command. Well, we are going to create a folder in your root of your application. It's going to be test. Then create a file called some.test.typescript. Third, copy this script, okay, and pass it right here. Delete this function. Is going to be expect 1 plus 2 equals to 3. Okay. We are going to add this script into package.json right here. Nice. Okay. Now copy this command. Okay, it's going to ask a bunch of questions. Would you like to use TypeScript? Yes, of course. We are going to use Jest too. You want Jest to add coverage reports? Yes. After this configuration, we will have a new file here called jest.config. In this file, we will okay. Let's go ahead. Now, we are going to install these packages. Open your terminal and paste nice. Then install this one as well. And install this. Perfect. Afterward, we need to install Jest DOM. Now, open package.json file, add another script. It's going to be type and the value is module. Okay. Now let's try npm run test. We need to install TS node. Okay. npm install save dev TS node. The last thing we are going to do now is to integrate Next.js with Jest. Since we are using Nextjs, we have to do that. This is very simple. Search for Next.js Jest config. Select this link and scroll down here. In this section, we are going to copy this script. Now go back to VS Code, open jest.config file and pass it just right here. Okay, let's import Next.js package like this and wrap our configuration with this function. Afterwards, we need to create this file. Make a new file in the root of your application called jest.setup.typescript and put inside this file this package. After this, open Jest configuration file, scroll down, search for what is the name? Setup files after env here and comment this line, and inside this array we are going to put this. Perfect. I'm going to try it again. Failed. Testing library. Okay, we need to install testing library. Testing library just to We finally did it. Great job. Now we are going to set continuous integration. Continuous integration is a software development practice where code changes are automatically integrated into a shared repository multiple times a day. The goal is to detect and address integration issues early and improve code quality in order to make the development process faster and more reliable. So the first thing we are going to do is create a new workflows. We have name, which is CI, this, an event, push, push on branch, main, and we might have jobs, with our name. Let's name it build. It's going to run on Ubuntu latest version, and our job has several steps like steps. Firstly, we are going to check out code. Check out code. And for that, we are going to use this dependency actions check out version 4. Another task is going to be node installation. Okay. Install dependencies. With npm install. So we need to actually give the node version right here. With node version 20 list. And let's add another task. It's going to be build project. By running this command npm run build. Another task is check out TypeScript errors with npm unit and integration test. By running npm test. So every time we push any changes in our repository, especially the branch main, this workflow will run. Now we are going to set up ESLint in order to run this command. Open package.json file and add ESLint script. How would you like to use ESLint to check syntax and find problems? We are going to use JavaScript modules, of course, with React, with TypeScript, and we want to run our code in browser. Afterward, we'll have a file called eslint.config.js. Right here, open this file, and we are going to add some configuration like ignores, which is an array. Inside this array, I'm going to put Nextjs build folder. Additionally, node modules folder, coverage test folder, and coverage. That's it. React version not specified in ES3 plugin React. File. Setting React version detect Once ESLint is ready, we can now run our workflows. So first of all, we are going to test continuous integration workflow. So go to your terminal and push your change into repository. Git add, okay, git commit, add workflow, git push. Perfect. The next step is, once this workflow is completed, it will launch another workflow. So let's go back to VS Code and select continuous deployment workflow. There, we are going to add another event like workflow run event, workflows get the CI workflow, which is completed and if GitHub dot event dot workflow run dot conclusion equals to success, you can continue. Okay. Now we should have two workflows. First one is continuous integration CI. When the CI is completed, the Vercel preview deployment will run. It's up to us now to build the database according to the design document, which is the process of developing an abstract module of a system to represent different perspectives of the same system. This module is done through UML. UML is a standardized modeling language used in software engineering to visualize, specify, construct, and document the artifact of a software system. It's used in object-oriented software design to help developers understand and communicate the design of a system. UML diagrams are categorized into two main groups: structural diagrams, behavioral diagrams. Structural diagrams describe the static structure of a system, showing its components and their relationships. And behavioral diagrams focus on how the system behaves over time. An example for structural is class diagram. Class diagram represents classes, their attributes, methods, and the relationship between them. To build database, this is the most important diagram you should focus on. For this project, I built class diagram using draw.io. This is an example of class diagram for a customer. A customer belongs to the category of user. They can add several products to the cart. They can also place one or more orders and create delivery addresses. Perhaps you've never heard about UML. I have quite a list of content you should look at to learn more. They are in the description of this video. In the development process, we will be focusing on building those modules. And this is what I'm going to do right now. First of all, as you know, we are going to use Mongoose. Mongoose is an object data modeling library specially for MongoDB and Node.js. Mongoose syntax is very easy and has a strong support, community, maintenance, and a growing ecosystem. If you used to deal with Prisma, Mongoose is a little bit similar with Prisma. Let's start creating our database. In development, our database is development database, which is ORION _dev. Let's create a collection called products. A MongoDB database is a group of collections. Each collection maps to a Mongoose schema. A schema defines the shape of the documents. Shape defines properties in a collection, for example. A product has a property called name, which will be cast to the string schema type. To build your database, we are going to create all schema for each collection. Let's start with product schema. Since we are using TypeScript, it's going to be a little bit difficult. Firstly, we need to define the type of our product module. Great. Secondly, we need to create a schema using the product module type we just created. So create new schema and then add types, and afterward add properties. Finally, we are going to create the module which is going to be saved into Mongoose modules. Now, sometimes Mongoose might rewrite your modules many times. So, to solve this problem, we are going to say, if Mongoose modules product already exists, please just take it, otherwise create a new module for us. That's it. This is the most easiest way to build schema for any MongoDB document using Mongoose and TypeScript. Now, to make things a little bit easier for you, I created all these schema modules on Swagger. Swagger is a tool to design and document APIs. By the way, all the APIs for this project is available in Swagger. All the links in description. You'll find not just APIs, but also schemas for rich models, which might help you to build schema for this project and also for your own project. Let's take the product module. You'll see properties and description for each property. For example, we have featured. Featured is a boolean with a default value which is false. Name is a string. Slug is a string. Description is a string as well. And they have a red flag, which means they are required. Since the main goal of this course is to help you building things at your own, I'm not going to build the entire modules literally, but I'm going to build the most important schemas, and I'll try to explain the most important concepts that you should know in order to help you building the rest of schemas. First of all, let's finish product module we just started. The first property we have is featured. Featured is a boolean and it has a default value false. The next one is name. Name is a string and it has this red flag, which means it's required. Afterward, we have slug, which is string 2 and required. Description is the same. Additional and specification are string and not required. Category is required. Subcategories is an array of objects and is not required. Collections and tags are the same. Now, brand is a string. Afterward, we have reviews, which is an array. And store as well. Store is required. Product variant is an array of objects and is required as well. Image is an array of string. It has a property called URL. URL is required. Price is a number. Discount is also a number with a default value. Status is a string which is not required, but it has a default value which is draft, and status is a list of data such as draft, publish, and archive. SEO title is not required. This is just a string. SEO description is the same things. SEO slug as well. Afterward, we have weight, which is a number with a default value. Unit is a string with a default string value. Inventory is a string, and it's also a list of data like in stock, out stock. The default value is in stock. Now we have SQU, which is a string, and it's required. We have user ID, which is required as well. Views is a number with default value. Finally, we have created at and updated at, which represent timestamp. I think for now, we've done with the product. I'm going to create two more schemas. The second one is category. Create another file in modules directory called category.typescript. It's going to be the same way. You can just copy and paste and then delete all the properties and then rename product to category. Or it's up to you if you want to create everything from scratch. So I'm going to create the type module for category, then create this type on the module TypeScript from types directory. Now we are going to create the schema for category. This is new schema. At this point, I'm going to create all the properties for product type. The first one is featured, which is a boolean. Name is a string, slug is a string as well. Description is a string, additional string, specification string, category, subcategory is type subcategory module. So make sure to create another type for category and subcategories. Collection is the same. Collection has its own type collection module. Tag as well. Brand also has its own informations. Afterward, we have review as well. Now, I built schemas for product module, category module, and token module. All you have to do now is build for the rest of the application, such as brand. You are supposed to build brand, page, payment, newsletter, pay method, tag, slide, shipping, campaign, review, address, slide item, cart item, collection, color, discount, image, order item, product variant, size, track activity, track order, withdrawal, store, subcat, subscription, and it's over. Now it's very simple. I have already built some example. Let's take a look to payment. We have subscription, which is a string. We have type, which is a string as well. We have checkout ID, which is a string. Checkout status, which is a string. So this is very easy. However, if you got some trouble, you'll find all the necessary content in the description, like source code, link, and more additional content. Now, we are going to set up Clerk. Go to clerk.com, click on Start Building for free. Now, try to sign in with your GitHub or Google account. Need to create a new account. Afterward, you need to create a new application. It will be YouTube ORION API. Then select any option such as GitHub, Google, email, and click on Create Application. Here, choose Nextjs as backend framework, and we are going to install all these dependency into our project. So open your terminal, install Clerk Nextjs version 5. Afterward, we are going to save API keys into Auth development file, and also we are going to create a file called middleware in the root of your application. By default, Clerk middleware does not protect routes. All routes are public and you must protect route yourself. This is what I will do. Here, what I'm going to do first is to get Frontend authentication token. And then I'm going to protect user API. So when the server gets a request, it will try to find if this request starts with API user. If the answer is yes and the user is not authenticated, it will return a response: you are not authenticated. Here, I'm going to protect API admin routes. And this is the same way. But with admin routes, we are going to use a metadata. And guess what? Clerk provides user metadata which can be used to store information. And in this case, it can be used to store a user's role, like public metadata. So we are going to implement basic role-based access control with metadata provided by Clerk. With Nextjs app router, any folder inside the API folder will be treated like an API endpoint. So I'm going to create multiple folders such as admin, user, and public. Admin folder will contain admin APIs. User folder will contain customer and seller APIs. And public folder will contain public APIs, which will be available to all. Now we are going to create our first API. What is an API? API, Application Programming Interface, is a set of rules and protocol that allows different software applications to communicate with each other. There is different types of APIs, such as web APIs. These allow communication over the internet using standard protocols like HTTP or HTTPS. For example, we have RESTful APIs or GraphQL APIs. The type of APIs we are going to create in this project is RESTful APIs. The first one is Public Tokens API. Public token APIs will allow you to access tokens in order to test authentication and authorization APIs. I created a async functions which handle HTTP post method, and inside these functions I'm going to create try catch statement to handle errors, then connect to DB. Afterwards, I actually need to get frontend request then I'm going to use Zod validator to perform server-side validation. Zod is a TypeScript first schema validation with static type, which means we are going to deal with a lot of schemas. That's why we need to create a file called schemas. Inside this file, we are going to create all schemas for the application. Each Zod schema is supposed to validate a form data. Thus, I'm going to create another file to handle every form data. This file will be form.ts. When integrating Zod with form validation, each field or input has its own validation. For example, we have template, which is a string, and it's also required. Another one, token, is a string as well, and it's required. We also have status, which is a list of data and must be one of those elements. It should be draft or publish or archive. So the thing is, status is not a required field. That's why I put optional. So here I'm going to say if the zode validations failed, then return a response with a message and with all the necessary error field. If server-side validation is success, we can actually save data into database. So this API is not supposed to be public. I am going to create another folder in admin API called tokens and a file called routes.typescript, and we are going to move this API in there. Clerk provides GWT templates so that you can test APIs in development. So I'm going to create two templates. The first one is going to be Auth token. And the second one is going to be admin token. For admin token, we actually need to add a custom metadata. Click on users and create a new user. We are going to use to test our APIs. This user is going to be an admin. So click on his account, scroll down and go to public metadata, add role admin. And I'm going to build the authentication pages to test the user we just created. For that, I'm going to create sign up and sign in page inside a new folder I'm going to create in app directory. This folder will be Auth folder. It's a group route. Inside this folder, we'll have a new folder called sign up. And finally, I'm going to create a file called page.tss. Now I'm going to sign in with the user. All right. The next step is to get tokens from GWT templates that we have created earlier. The only way to get these tokens is by using console log. So this is the script. Copy the script, go to your project development, open your console, paste the script and hit enter. Afterward, your token will show up. It's up to us now to test our API. And I'm going to use Thunder Client. Thunder Client is a lightweight REST API client for testing APIs. The most important thing is this is a Visual Studio Code extension. So let's get into it. Thunder Client is a RESTful API client which is used by more than 4 million users in the world. It's very easy to understand and you can use it directly from your VS Code editor. First of all, download this plugin. Then go to Collections. Create a new collection. It's going to be YouTube API. Then you can create a folder which is admin folder. In admin folder, create another folder called tokens. Tokens should have a request which is going to be a post request. Then add the API endpoint which is localhost 3000 API admin tokens. Afterward, do not forget to save that, and we need to get token from GWT template right here. Just copy and put this token in bearer token form. So now we need request body data. But first of all, this is not the right token. This token is Auth token, which won't pass. So we need to get admin token. As a result, go back to console log and change the name of the template to admin token, hit enter and get the new token. We just added a new token into database. Let's see. This is great. Good job. Now, let's perform another APIs. For this one, we are going to get tokens and it's going to be a public API. This is going to be very easy. First of all, create try catch statement, connect to DB. Afterward, we are going to get queries from the URL. Especially in particular, we are going to get template query. So if template query does not exist, return a response with a message like template is empty. But if it does, go ahead, find token that match with this template, and also a token that is published. I put draft because there's no published token right now. But the idea is to get a token which is published. So let's test that one quickly. Let's say if there's no template query, we have response template is empty. Great. Now, if we put a template query, which is false, there's no token. But if we put the right one, we have actually a token. Great. Now, I think we are good. We are actually good. But let me do some quick review. Instead of getting all of these properties like template, token, status, I just want to have token. Now we are pretty good. Let me make a quick review of what we've done so far. Great. As you know, I'm not going to build all APIs for each schemas. It's up to you now to build the rest of the APIs. You have everything. You have schemas, you have examples, you also have source code. Now, we are going to set up CORS. CORS, which is cross-origin resource sharing, it's a security feature implemented by web browsers to control how resources on a web page can be requested from a different domain than the one that serves the web page. So by default, web browsers enforce the same origin, which means that a script on a web page can only make requests to the same domain from which the page was loaded. With Nextjs, this is very easy to set up CORS. First of all, open the file next.config.mgs. Inside this file, you will have a next config object. Inside this object, create an async function, which is headers. Inside this function will return an array of objects. This object has many attributes. The first attribute is source. Source is the path of the API endpoint. You can specify a single endpoint like API admin tokens, or you can specify multiple endpoints by defining just a path. The second attribute is headers. Headers is an array of objects. Each object have a definition. The first one is the access control arrow origin, which define which origin should have access to your APIs. If you put star, anyone can access your APIs. Otherwise, you can just specify a URL, for example, localhost 3000, and this is going to be this specific URL that might have access to your APIs. Second object is access control allow methods that define which method the origin can use. It can use get, post, put, delete options. The last object is for access control allow headers. This define the content type authorization. In our case, this is bearer token. Let's build one more APIs. Afterward, we'll deploy our project to Vercel, and I will show you how you can document your APIs using Swagger. Let's get into it. I'm going to build APIs for brands. So brand should be performed by admin. It means you need to be an admin to create, to update, to delete a brand. But a brand should be accessible from anyone by using public API. So go to API admin, brand, create a file called route.ts. Inside this file, we are going to create, to update, and to delete. Great. Now, let's start with the first one, create. I'm going to export or async function called post. Post is the HTTP method, and inside this function, of course, I'm going to get the request. We'll start with try catch statement, and we need database connection to save data. After that, we need to get body request from Frontend. This body should be validated by server-side validation, Zode validator. So I'm going to create, of course, a schema. Which is brand validation schema. Before create this schema in schemas file, I'm going to say if this validation failed, return a response with a message validation errors and with all of necessary errors filled. Oops. Finally, we are going to create this schema. Okay, now I'm going to define a form data, which is brand form data for our schema. So go to form file and create a new type, which is brand form data. Each field will have a validation. For example, name is a string, description is a string, but also this is not required. Slug and image is a string, and they are required. User ID is a string. The last one status is not required. One thing very important is when an attribute is not required, you do not need to put it in the form data. If you want, you can, but don't forget to define that this is an optional attribute. Otherwise, you will get an horrible error when you will try to submit your form. I think I talk too much, right? Maybe I should shut up a little bit. How to set up course with Nextjs. First of all, course stands for cross origin resource sharing, and it's a security feature implemented by web browsers to control how resources on a web page, like APIs or images, can be requested from a different domain than the one that served the web page. Okay, I'm back. Now we are going to perform update request. This is the same thing as the last one, post request. But here we need database connection, of course. We also need queries, especially the ID. We need the ID of what we are going to update. In this case, it's going to be brand. We need ID of brand. So when we got this ID, we will try to make sure this is a valid MongoDB ID by using MongoDB function is valid object. Very important. If the ID is not valid, return a response with a message, your ID is not valid. But if it does, okay, we can go ahead and now we can be serious. Now we are going to get the request body, and as always, we are going to update data using find by ID and update. This is a Mongo function which takes the ID as first argument and the request data as second argument. So I just copied the ID of the brand. I'm going to put it on query section right here. Of course, in addition to the ID, we also need the request data, and that's it. Now, the last one, delete request. Delete request is similar to put request because we are not going to delete completely the brand from database. We just need to update the attribute which is status to any value, from any value to archive. This is very simple. So it's going to be brand find by ID and update, which takes the ID as first argument, and the second argument will be the value of the status attribute, which is archive. So remember, every schema has a status. Status has at least 3 values: draft, publish, and archive. Draft is a value which means that the data is not published. It cannot be available online. But when the status is published, that means your data is available online. When the status is archive, that means your data is not available at all. The last one is get method. This one is a public API. This is the API we are going to use to get data for the online store. So it's supposed to be public. Now, inside these functions, we are supposed to return an array of brand or a single brand, either an array of brand or a single brand. In case this is a single brand, we are going to get the ID of the brand from queries, and as always, we'll check if this ID is valid or not. If this is not valid, return a response, your ID is not valid. Else, second case, if we do not have an ID, it means we are going to return an array of brand. So connect to the database and perform a brand and perform a Mongoose query finds on brand module to get all the data with status published, to get all the data published by the admin. Very simple. Okay, I'm going now to test this API. Now we've done, we are going to push our content into a repository. For that, I'm going to run git add, git commit, and git push. As we have set up GitHub Actions in our repository, we'll have two workflows which should run. The first one is continuous integration, and if this workflow is completed, it will automatically trigger the deployment workflow, which is going to deploy our project to Vercel. Great. In the meantime, let's update our Vercel project environment variables. Go to your Vercel project and select a project, go to setting, click on environment variables, and you should add variables for each environment. For example, if you're in test environment, add test information like test database and other keys. Okay, this is for test database. We also have a production database. So go to database project and add the database name for your project environment. Also, we have Clerk APIs, which will be the same for both test and production environment. So, one thing very important, every time you update your environment variables, you should redeploy your project. Let's see if we can actually perform a token API. Great job. The last part of this video is API documentation. We are going to document our API using Swagger. Swagger is an API documentation tool that we are going to use go to the website, create a new account, and from your dashboard, click on Create API. You will have a form that you should fill, give a name, a project, the version of OpenAI, which is version 3, the template, select None, give a name to your API, give a title, description, visibility. After that, click on Create. When you submit your form, you will be redirected to this page. This is where you are supposed to build your documentation. So first of all, you need your API URL. So copy your API URL. And then replace it by the name, and then replace your URL by the URL of the server. You can also provide your information such as email, website. You can also edit the title of your API, the description of your API, and so on. Now, the first thing we are going to code is tags. Tag is like a group of API. For example, recently we built API for brand like create, update, and delete, but also we have brand API which is public. So you can create a tag called brand, and this tag will wrap all the APIs for brand. The next step is to create path. Path is like API endpoint. For example, brand has two API endpoints, such as admin brand, public brand. Now, let's take a look to admin brand. Admin brand has a post request, has a put request, and a delete request. In the other hand, public branch has get request. So we are going to create all of these requests. The first one is post request. The first thing to do is to define the tag of this path. Admin brand tag is brand. So we define the tag of this path, also a description what this request is supposed to do. Afterward, we have request body. The request body has a content type which is application JSON. It also has a schema. The schema type is object, and there is some required fields and optional fields. You should define all the required fields for brand, which is name, description, slug, and so on. After that, we are going to define all the properties. A post request also have a response. We should define the status of this response. For example, 200, a description, which is the message that should display about this response. Afterward, we have the content type of this response, which is an application design. Also, if your response should return a data, you should also define this type of data. To define this type of data, you should create a component and define the schema of this data and define the schema of this data inside a component you can name response. And to define this type of data, you should create a component called response and define the schema of this data. So the type will be object and it has required field, which is status and data. It also has some properties that should be defined. Now we've done with post request. I'm going to create the get, put, and delete request. The GET request has the same thing as the POST request, but the GET request does not have a request body. Instead of this, it has a parameters which is used to get queries. This is the most important part, which is setting authentication and authorization. You need to create a component called security schemes. Inside this component, you should define what kind of security you need to perform. It can be bearer token. So create a security called bearer auth. Define the type of this security, which is HTTP, and the scheme, which is bearer. After that, you should set this security for any request you want to secure. For example, it can be post request you want to secure, or put or delete. You will be able to define a token. This token is, you can get this token from public tokens API, and it depends on what kind of authorization you need. It may be just for authentication or just for authorization. As we have created two types of token using GWT templates, we have Auth token for user. We also have admin token for admin. So if you want, for example, to test brand API like post brand or update a brand, you need to get admin token. So all you need to do is to copy this token, go to Swagger website, put this token inside, and connect yourself in order to have access to test admin API. Congratulations! If you are still there, it means that you are aware that you should finish your task, which is building all schemas for your database, and also build and test APIs for all schemas. I encourage you to finish it because it will allow you to build things at your own and to improve your problem-solving skills. In this part, which is for backend development, you have learned a lot of things, such as understanding API principle, understanding Nextjs basic concept, building robust APIs, securing API with token and authorization, securing API with CORS, DevOps CI/CD with GitHub Action and Vercel, documenting APIs. In the next part, which is front-end development, we will build the dashboard for admin and seller, but also the entire store. This second part will allow you to improve your front-end skills, such as learning how to integrate a full Figma design from scratch using Tailwind CSS and Nextjs, learning responsive design using Tailwind CSS and Nextjs, learning how to structure your front-end application with Nextjs, learning how to create reusable components with React and Nextjs, learning how to integrate RESTful APIs, integrating client-side validation with Zone Validator, learning Nextjs optimization such as server-side rendering, static-side generation, client-side rendering, incremental static regeneration, learning Nextjs SEO concept and practice, and finally, testing your application with Cypress. Thank you for watching this course. See you in the next part.